Yeah, I think. Okay. Hello? Am I audible? Yes. In this?
Yes, sir. You are audible.
That's great. Show my screen. Just a moment.
Good morning, all. A warm welcome to all. Now we have 31 participants logged in, and we have some more participants just leave it. We can start on time. So we have Arpan sir, Arpan Pal sir. So I hand over the mic to Arpan sir. So this session all yours, sir.
Thank you, Yashika.
Yeah.
And thank you everyone who's joined the call so far. I'll just share my screen, so just let me know if you can see my screen that way.
Yes, sir. Now it's clear.
Okay, great. So are we expecting other people to join the call as well?
Actually, some more participants are remaining, sir, but no issues, sir. They may be late. We will call one by one. No problem, sir.
Okay.
So we can start, sir. That will be better.
Sure, no problem. This platform is a bit different from the one that I did last time. So I think I will need your help, Shrikant, on the way if I need to draw something, or if people can share the screen. I mean, if I draw something, so can other participants draw in that same platform? Okay, I have to give control.
Okay, sir. Okay, sir.
Okay, great. So I think most of your today's session will be around the building physics aspect of ECVC. Building physics aspect in the sense is by how you can influence your design through various ECVC parameters, and in process how you can make your building ECVC compliant. And we look into all those factors and parameters in details. The one that we showed yesterday, that includes the building envelope, then the electrical systems, and then control and thermal comfort, and then renewable systems, etc. But the starting of this session will be given to building envelope and the science behind it, and how you can make your design changes into this so as to make your building as a ECVC compliant thing. So what I'll do, and then in between and towards the end of the session, what we can do is we'll start with the Equest software. So people who are in the in this year's session. So has everybody installed Equest on their system? How can I take a poll on this, Shrikant?
Hello, sir. They can respond in the chat. It will be possible for them to respond on the chat.
Okay. Okay.
Okay. Yeah.
Oh, okay. So I rephrase my question. Has anybody not installed the Equest thing? If not, you can still you download it and you install it. It's a freeware. It is not that heavy. It's not graphic intensive, so it will be light and a quick thing. So if anyone has not yet installed it, please do so. And I'll go through the first aspect of the building envelope section. But just before starting, I would just like to have an idea how many of the participants are architects or how many are engineers, so that I know what to press upon and what not to press upon.
So out of the attendees, majority of them are architects and civil engineers, and like 1/3 of them or 1/4 of them would be mechanical engineers. But the majority is architects and civil engineers.
Okay, great. That's good to know. Okay, so let's come to the first slide here. So as you can see, we'll focus on the building envelope aspect of the building now, of the ECBCA code. So yeah, this is the first component of a building that ECBC scope applies to. As we have shown you yesterday, what building envelope means is that it is the surface or boundary that separates the external environment from the interior spaces. This includes the roof, skylight, windows, external wall, both above ground and underground. And then if there are yeah, interior yeah, spaces as well, but interior walls and ceilings, they are not as much influential in this as the roof and the external wall and the glass. Interior ceiling, floor, and your internal partitions, they do not well influence the energy consumption of your building that much. It is just the other aspects, that is the skylight, the fenestration, the roof, and the external wall. In fact, the underground wall as well. If there is a basement, that is also influential. So as you can see, that the basement walls, the slab on floor is the surface that is in contact with the ground. That is important. The external wall, the roof, the skylight, and the windows. These are the various things for which ECBC has a requirement, right? So as we can see that how building an envelope can influence your design. First of all, they look for a visual comfort. Now your visual comfort in terms of people looking from outside as well. It is aesthetics, as well as if you have a good building envelope that do not allows for much glare inside or something. That is so having a good building envelope can influence that also. Thermal comfort is the main thing that your building envelope influences. If you have a bad your building envelope, you may feel or too hot or too cold depending on the weather outside. If you have a good building envelope, then you will feel much more comfortable yeah, inside if the conditions outside are harsh. But of course, keep in mind that it's not just building envelope. You also need to have a good system, good HVAC systems, good HVAC controls to have good thermal comfort and yeah, inside. So, for example, if you have your building in in a very cold region, no matter how good, I mean, you can invest a lot in the building envelope. I mean, good, give heavy amount of insulation and all, but still, I think you would need some level of system heating inside the building to keep you thermally comfort. And then the third thing that building envelope design can influence is the energy efficiency. So we will see that through.
May I interrupt, sir?
Yeah, sure.
Yeah, sir. Your slide is not full screen. Yeah, the same thing.
Okay, this one. Actually, what happens
Yeah,
if
sir.
I make
And display settings.
both my screens goes into this one? Okay, display
Okay, in that
settings.
display settings, can you go to
Okay.
display settings, sir?
Hmm.
And first one,
First one.
sir. Yeah.
Okay.
Now it's clear,
Okay.
sir.
Okay. Great.
Thank you, sir.
In display settings, there is one duplicate slide view. Okay. Oops, no, not this. Not it. Wait, how do I change this again? Oops. Wait. Sorry. If I go to slideshow, right? Is this all right?
Yeah, sir.
Great. Okay. So as I said, so this is mainly so only the three ways a building envelope can influence the design is through visual comfort, through thermal comfort, and energy efficiency. Now, yeah. So how building envelope mostly now the way the building envelope works is through basic heat transfer principles. As we all know that heat transfer generally takes place through conduction, convection, and radiation. It's the same thing that happens. So what happens is your building envelope is the main component that stands in between a very harsh climate outside and the inside where you are. So yeah, I mean, I'll just quickly go through these slides. We will share these slides here with you for you to have an understanding of your conduction, convection, and your radiation. What I'm trying to do is I'll just quickly go through these basic slides so that I can give more time the Equest software, which is the main reason why this training session is taking place. So here, as you can see, that uh, the heat transfer in the building, the opaque element, that is your opaque walls and your roof. Now, how so a majority of the solar radiation that is falling on the wall is absorbed by the heat wall. Some of it is irradiated back, some of it is reflected back, and then the absorbed, and a part of the absorbed heat is then passed on within the building where you want your thermal comfort to happen. So this is the way I've been from outside, how it goes in. Now, that is why it is very important to have a good building envelope that can insulate you, that can protect you from the harsh your solar radiation inside. No, sorry, that is coming from outside. Again, the same thing happens for glass. Just the cases in the glass, the heat transfer is much higher. A lot of well, as it is not opaque, a lot of the transmission takes place through radiation as well, and the conductive heat also enters into the space through the fenestration. Again, having a good quality glass will again help you to reduce those heat gains within the building space, so as to keep you comfortable inside. Now, the main thing here is what determines the property of your building envelope, and how would you know that yes, my building envelope is good enough or not. The main thing is the R value. R value stands for the thermal resistance. Now, as you can see from the formula here, it is the measure of resistance to the flow of heat through a given thickness of materials, with higher number indicating a better insulating property. So that means if my R value is higher, that means my building envelope is more resistant to the heat transfer. That means that if the outside temperature is too high, right, then my wall or my glass or my roof is more resistant to the heat transfer that wants to get inside your building, right? This is the main and your understanding of the R value. And how do you calculate the R value? It is the thickness of the material divided by the thermal conductivity of the materials. Now, these thermal conductivity, these are values that are provided by your manufacturer, right? You need to ask your manufacturer the exact thermal conductivity. I mean, these are available on the technical specification sheets as well. So you can easily get these figures, and then you know that okay, I am planning a 250 mm AC block. I go to the AC block supplier and I ask him that okay, just provide me the thermal conductivity of the matter. If he or she has it, they will provide it. If they don't have it, they'll go and get it here tested. ECBC also provides that as a mandatory requirement of how to test or what formula to use for the U value calculation. Also, a mandatory requirement, we'll come to that in the later slides. One of the mandatory requirement is that you need to test the U value of your material, whether it be insulation, whether it be your bricks, whether it be ACC blocks, through a third party independent lab according to a specific standards. That standard is ISO. We'll come to that later. So sorry. So as you can see, so if you have say this section, 250 mm AC block, 12 mm internal plaster, and 12 mm external plaster. So your R value is your R value is the combination of all these layers. If you have a layer of insulation somewhere here, you let me try this drawing to see if this works or not. Okay, so say if you have this is Shrikant, any idea how do I yeah, okay, so say if
Hello? Sorry, sir.
yeah, got it.
Is it
So
okay?
if I have an insulation layer here, right, and then this say is a this is a say 120 mm brick here, and here also 120 mm brick, then the entire R value will change. So in this case, you will have uh, uh, 4 different materials. One is the plaster on the outside and inside. One is the brick that is there in 2 walls, and then there is the insulation layer in here. So these are the ways you have to see that okay, by having which combination on my external wall or roof will give me the RT value that complies with ECBC. Now, of course, you need to keep in factor the cost implications as well. If you do not have that much of your budget, you have to see that okay, where I can trade that off. We'll come to that in the later section of the your presentation. So here, if we have these 3 different materials, your D1 will be the first. So say D1 is the first material here, right? D2 will be your second material, which is the insulation, right? D3 will be your brick, and again D4 will be the another layer of ये plaster. So the total the resistant so the total resistance value is the addition of the first material divided by the first material's thermal conductivity added with the second material diameter divided by the second material conductivity, and then so forth. So the number of layers that you have, you will have this many number of components in your R value calculation. So here, as you can see, there is a small calculation here. If say your 12 plaster, so your D is 0.012. The K value of plaster is 0.15. Now, as I said, that these values you either have to get it from the supplier. Just ask the supplier for the K values they can provide you, and then it's just a matter of 0.012 divided by 0.159. That gives you this value. Similarly, you calculate the same for the 250 AAC block, and the same value for the 250 I think there is a mistake here. I think this should be 1, 2. It's the same value should come 0.08. It's not right. So either you can consider to just club them or have 2.08 plus 0.15. Yeah, because the final is like that only. Anyways, and then add all these components to get the final R value. Now R value, as I said, it is just the component where we determine what is the resistance of my building envelope. But in ECBC, the main thing is, the main thing is the U value. How can I remove this? Oh, erase all right. So now, but in ECBC and all other parameters or all other standards that you will see, I mean in ashtrays as well, in any green building certification, the main parameter for thermal conductance for judging whether my building envelope is good or not is U value. Now U value is the reciprocal of R value. So just like R value, if I have a higher R value, that means I have a good building envelope. As U value is the reciprocal, that means lower the U value, better my building envelope. Right. Now, just a very small difference. When we say U value, we mean the thermal conductance of a single material, right? But when we say U factor, so if you see the ECBC code, there the opaque envelope structures are given in terms of U factor. U factor means the combination of the overall assembly. So what is U value? It shows the amount of heat loss or gain in watt per square meter of material when the temperature outside is at least 1 degree lower. That means for a 1 degree Celsius change in the temperature outside, how much does my building allow? How much does the building allow? Your building envelope allow the heat to transfer for a change in 1 degree, right? From the outside to inside. So that means in over 1 square meter of wall area, right? How much watt is transferred through if my delta T, that means the temperature outside is ये changes ये by 1 degree or say 1 Kelvin, I mean, right? So that is what U value is. Up till now, are there any questions? You can please feel free to write anything in the chat, or you can unmute yourself and say as well. Shrikant, can we make so can all the participants speak up, or are their mics automatically muted?
Sir, actually, they can ask questions
Okay.
or questions by chat box
Okay.
mainly,
So if you have
or
any,
they can raise hands so
okay,
that we
that's
can.
great. So if you can, so are there any questions as of as of now? Please feel free to ask. Okay, I believe there are no questions for now. Okay.
Just a moment, sir. One Shobhana Subramanian, I think she has a question.
Okay. How do I know given someone has raised hands?
Shobhana ma'am, you can ask. Sorry, sir. Yes, I think she has some problem. I'll contact to her. No problem, sir. So.
Okay. 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 So as we can. So as we can see, just like that. So the difference. So you can use this calculation method given here and here to come up with the U values and the R values of certain options of your building envelope. So, for example, this is a calculation for a conventional brick wall. So that is just 230 mm brick with 25 mm plaster on either side. That if you calculate using the formula above, you will get a U value of 1.7 watt per square meter Kelvin and the R value of 0.158. So 1 by 0.158 is 1.7. So as U value is just the reciprocal of this, if you do that, you'll find that they are both interrelated. Likewise, if you have a AC block with insulation, that means you have a 200 mm AC block, 25 mm plaster on either side with a 75 mm insulation as well. So here you can see how the U value differs from a conventional brick wall to a AC wall with insulation. Here, in case of a conventional brick wall, the U value is 1.7, but in case of an AC brick wall with insulation, it is 0.42. That means that it is that lower the U value, the better is your block, and the higher the R value, the better is your envelope. Right? Now, based on ECPC 2017, these are the various U factors that are prescribed by ECBC for different climatic conditions. So as we saw yesterday, that there are 5 climatic conditions. What I can do quickly is show you the climatic. I think that is easier. Yeah. So this is ECBC 2017. So as you can see, that entire
Sir,
India is.
there is a question from Catherine Selvaraj.
Yep, please.
Can you explain U factor again?
Okay, U factor. Okay, sure. You mean how to calculate it or what? Okay, I'll explain it again. So what U factor primarily says is it is a property. It gives the property of the wall, that how my wall is immune to change in temperature from inside to outside. That means that if my inside temperature is say 25 degree and my outside temperature is 26 degree, then what the heat transfer will be through the wall, that is what U value says. So if you have a U value that is lower, that means that the building envelope is more resistant to transfer heat from one side to the other side, right? That means that if I have a lower U value, I will feel much more comfortable inside than a building envelope if it has a higher U value, right? So as shown in this one, I'll just yeah. So as you can see here in this, for a conventional brick wall, right, U value of 1.7, but for a brick wall, for a wall that has AC block with insulation, we have a U value of 0.42, right? That means 0.42 watts per 1 square meter of wall will so a heat transfer from 1 square meter area of the wall will be 0.42 for 1 degree change in temperature, whereas in this case means that 1.7 watt per meter square of wall area will be the heat transfer for 1 degree change in temperature. That means the heat transfer will happen much more higher in case of a conventional brick wall as compared to a AC block with insulation. Is that clear, or you need to or do you want well, or did I not answer your question? Hello.
Sir, it's clear, sir. Thank you so much.
Okay. Thank you. So we come back to this where so we say here that ECBC 2017 requirements for a roof assembly, right, for ECBC compliant building is 0.33 for all buildings except school and hospitality of these ranges, right? So as I showed you, that when you first try to determine whether your building is ECBC compliant, the first thing is to identify that which climatic zone does my building fall into. Now, these are the various climatic zones that have been divided. So if you see that this entire part is hot and dry, there is warm and humid, there is temperate, cold, and composite, right? So, for example, if I look into Kerala, so any building that is coming up within Kerala, that will fall as warm and humid. So, after determining what my where my building will fall, which is warm and humid, I will go and only check this warm and humid thing here, because in that case I don't need to worry myself that what are the values. The first thing is I determine, okay, which is my climatic zone, and then once that is identified, we saw that this is warm and humid. We'll just go and why is it not? We can go and just concentrate on this part. Now everything that we will see will be of the warm and humid place. So we can ignore everything and not confuse ourselves later on. After you have determined which climatic zone your building falls into, everything, so half of your confusion is gone. You can only concentrate on those figures that are for the warm and humid temperatures. So for here, I can see that all buildings except school and hospitality should have a maximum U factor of 0.33, right? Now, in that case, what you do is, sorry, yeah. So in that case, what you do is you say you come up with 2-3 scenarios. Yeah, like if you want to do say a cost analysis, that okay. One of my criteria is I should be ECBC compliant, and second is that okay, I need to have uh, uh, a cost effective building envelope as well. So you can vary these things based on, so one scenario you can see that okay, if I have an insulated wall, what would my U value be? Now in this case you have now this is for an external wall. So if I come here and then if I see that external wall requirement for warm and humid is 0.4 watt per square meter Kelvin. That means if I choose a conventional brick wall in Kerala, which is in warm and humid climatic zone, 1.7 watt per, so a conventional brick wall will not be uh, compliant for ECBC, right? Even this one, if I take 25 plaster on either side, 75 insulation, and 200 AC block, it comes to 0.42. Whereas your requirement as per ECBC for all buildings except hotels, businesses, and school, right? It is 0.4. So this envelope is also not meeting. Either you have to increase one of the either, I mean, you can just increase some of the plaster inside and see how this gets affected. You can also try some other insulation to, or just increase the insulation, but that will depend on what is your cost implications. If you can achieve the 0.4 with increasing the plaster, you can go ahead. If you can achieve this by increasing, adding a bit more air, air gap in between, have a small cavity somewhere in here, or add one more small layer of low cost insulation so that you can meet this 0.4 factor. Then you can do all those calculations here. But this is how you see, right? So similarly, any questions in this? Okay, so I think I assume that there is no immediate questions. So here you can see that based on warm and humid, you can and based on your
We have some
aspiration.
questions.
Okay,
Just a minute.
yeah. Is it
Yeah,
coming
it's
on this platform somehow? I'm not able to
yeah,
see
that's
that. You can see here, I'm not able to see any questions.
Deepa ma'am, you
Okay.
can ask.
Hello.
Yeah. Hello. Yes.
Sir, can you explain the other units of U value? Because in Equest, we are using it in BTU.
Yeah. 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 I mean, it is just the same thing. I've been BTU. Now the conversion factor from watt per square meter Kelvin to BTU is a factor of 5.678. That means I'll just quickly go if I just quickly share calculator. So for example, if your U value requirement for warm and humid is 0.4, you just divide it by 5.678. This 0.07, this is your requirement in BTU factor that is required in Equest. So the factor is 5.678 in here.
Okay.
Okay.
Okay. Okay. Thank you.
Yeah, yeah, I can understand that. So Equest is all in IP, whereas ECBC is mostly SI because we use SI, whereas as Equest is a US Department of Energy software, their unit system is IP. So yeah, that is the main reason of this difference. Okay. So I hope now how to identify and how to calculate your U value for your roof and your wall is clear. So now moving forward, if you have a section, what you can do is you can quickly go to an Excel sheet, do the small calculation over here that was provided, this one, and can see that okay, my total R value is here this one, and then divide that by 1 and see that okay, this is my U value. Then you can open EC and check okay, if I'm targeting for ECBC plus, sorry, if I'm targeting for ECBC plus, then I need U value of 0.34. That means I have to add some more insulation. I have to have a cavity wall or something, right? And then all those calculations you can see. And the same exercise goes for roof. So what I can, so I would just try to make this session a bit interactive. I'll just open an Excel sheet, and as I understand that there are architects in the group, so if you can just give me say a sample wall or a roof. So as the wall calculation is there, I'll just use a roof section in this. Just understand that okay, what is the total U value, and we can go through that process of calculating the U value, and then we can see that if that is compliant or not. So if you want, you can please write it. Just give me your typical section that is common in your region, so that we can just quickly do some calculations. You can either say or you can type the section in the chat. Any inputs?
No, sir.
Okay. So I'll just quickly say that it's the same thing. Say we have say RCC of say 200 RCC, right? Say we have 75 XPS insulation, right? And say we have about say 100 yeah, say just 100 of brickbat, right? So this is 75 insulation, that means 0.07. This is 0.2, and then this is 0.1. And thermal conductivity, again, we can take those figures, a bit of figure from here. So for I mean, this is for okay. So if we can get, let me see if I have that document for. That is there was a there was a MNRE document. Trying to find it. Yep, this one. This one is an MNRE document. So here, if you can see, they give these standard property building materials. So here, from here, you can take the thermal conductance. So I'll just say, okay, RCC is 1.58. So I'll say, then plaster is 0.721. No, sorry, we don't have plaster. We have XPS insulation. XPS is also provided here. Yeah, expanded polystyrene is 0.035. And brickbat cover, we use that for brick. We use burnt brick, which is 0.811. Right? So how it goes is this divided by this. So we get this, we thing, right? And then you auto sum this. So this is your R value. Now what your U value is, equal to 1 divided by this. So 0.41 is your U value. Now this is in watt per meter square Kelvin, right? So this is the way you can just add your sections, add the diameter, ask the supplier for the conductance, for the conductivity figures, and then see that okay, my resultant U factor for the roof, I'll not say value, I'll say factor. U factor for the roof is 0.42. Now I go back to the presentation or to ECPC to check, okay, where does 0.4 stand? So for me, if I want to make my building ECBC compliant, I need 0.33, whereas my is 0.4. So that means 75 mm is not here working. So I need to go and check that, okay, if I say increase RCC, just say, saying 3. So I'm seeing that, okay, just by increasing 100 mm of RCC, it is not impacting my U value that much. But if I increase my insulation, say from 75 mm to 100 mm, then see my U factor drops down tremendously. You keep an eye on this set. So if I'm doing 0.75, 0.075, it is coming as 0.4. But then if I am increasing my insulation from 75 mm to 100 mm, then it is 0.32, which means I am lower than 0.33, which is my requirement for ECBC compliant building in the warm and humid region. Right. I think what I'll do, I'll just quickly run through these because I want to start with the Equest this session only because it will take time for you to grasp those things and understand. So one of the main things, if you don't want to go into Equest and then do your calculations, this is a quick way that you can easily identify that whether your roof or your wall is compliant or not. We'll just quickly go through, and then we come to the Ssgc. Now, Ssgc is a property of the glass, right? Now, what it is a ratio of the solar heat gain that passes through the fenestration to the total incident radiation. So, say X amount of solar radiation is falling on the glass. What is the percentage of this that is being directly transmitted within the space? That is what Ssgc provides. Now, this indicates how well the glazing or the glass and fenestration product insulate the heat caused by the falling directly on the glass. So just like U value is there in terms of opaque surfaces, U value is also there for fenestration, but in that case, for fenestration, Ssgc is the primary reason for heat gain within these spaces. So how does Ssgc mean? Lower the Ssgc, that means lesser heat can pass through the glazing. Sorry, I always forget this. Yeah. So that means lower the Ssgc, lesser heat can pass through the glazing. Glazing units with lower Ssgc will help reduce the air conditioning energy use within the during the cooling season. That means if my Ssgc is lower, lesser heat will pass from outside to inside, and if lesser heat is passing from outside to inside, that means my cooling requirement for the space will be lower. Now, there is also another factor which is called the shading coefficient. Now, shading coefficient and Ssgc are interrelated by a factor of 0.87, right? So Ssgc, if Ssgc is 1, no, sorry, if Ssgc is 1, shading coefficient is 0.87, right? So as you can see that SC, like shading coefficient, is typically indicated for the glass alone and does not consider the effect of the frame. So if you see a glass, what are the different components of the glass? One is the glass itself, the other is the frame, and the third thing is the shading, if there are any shading element. Now SC is just a property of the glass, right? Ssgc is the property of the overall glass assembly, right? Whereas shading, this Ssgc is a combination of the glass, the shading, and the frame all together, right? Now, how do we calculate the Ssgc of an entire window? The calculation is maximum Ssgc divided by the multiplication factor. If you see this section here, right? So effective Ssgc. So whenever you calculate Ssgc, you have to calculate the effective Ssgc, right? Now, effective Ssgc is a combination of the assembly and the shading provided by any shading element, if there is any. If if there is no shading element, then that factor will not be there. This M factor component will not be there. In that case, your maximum Ssgc is your effective Ssgc. So, as you can see here, effective Ssgc is the cumulative solar heat gain coefficient of the fenestration with both the glass and the shading device. There are two important components of this that needs to be determined to calculate Ssgc of a window. First is the projection K factor. This projection factor is a factor of the shading. Now, if you see this is the formula for the projection factor. That means how much my my shading extends out of the wall divided by the distance from the bottom of the shading to the bottom of the glass. So when you the first step towards calculating the effective Ssgc is finding the projection factor if there is any shading. If there is no shading at all, then you just take the Ssgc of the glass, of the assembly that is provided by the manufacturer, right? Now, after determining what the projection factor is, okay, I'll just quickly go through one of the calculation here so that we can come to this. Just trying to find the projection factor. Yeah, see, Yeah. So after you come, so after you see the projection factor, the second component of what you have to see is what your this no sorry this is DF factor. Hmm. So yes, this is so there is a calculation where you can see what your projection factor is. I'm just trying to find table. Yeah, I think this is the table. So yeah, now this gives you the M factor. Now these are the values of the M factor that are there, right? Well, or the M factor is also called the shading equivalent K factors here. Just go to this. Yeah. Okay. Now, if you can see that when the fenestration is provided with overhangs and or vertical fins, a separate M factor shall be determined for each orientation and unique shading condition. The multiplication of the factor is derived from the projection factor and is calculated based on 4 ranges of a projection factor, that is 0 point. So after determining what your projection factor is, you have to see that yes, you have to see that which factor, I mean see that where your latitude is. So in this case, if the latitude is within a 15 degree north, you see that okay, what is my projection factor coming in here? If I have just overhangs, I'll just choose so this is the projection factor that is here coming. Based on this, I'll choose what my I think this part in ECBC 2017 is very vague. This is very well given in the earlier ECBC version, which is the 2007 version. What I can do is I can share with you that table based on which you will find what your M factor is, right? Well, and then from that table you determine what your M factor is, and then divide the maximum Ssgc that is provided by the manufacturer by this multiplication give factor to get the effective HS, to get this effective HS Ssgc. Now, these multiplication factor, they depend on the orientation. The multiplication factor is different for north orientation. It is different from south, east, uh, uh, and west. Now, based on which side your window is located and your projection factor, you will determine what the M factor is based on that table, and then you will divide the manufacturer provided Ssgc by this M factor to get the effective to get the effective Hsgc. Now there is a table here. I'll just show you. Yeah. So as you can see, as per the requirements of ECBC, based on hot and humid region, the maximum U factor of the of the entire assembly can be 3, and maximum Ssgc on non-north sides will be 0.27, and maximum Ssgc for north side for buildings lying above 15° north latitude will be separate than the maximum Ssgc for north facing windows for buildings lying lesser than give 15%. So in this case, based on just the identification of the M factor and finding the effective Ssgc, you will see that, okay, whether that figure matches here or not. Now I'll just can just like this, I'll do a quick calculations. Say my projection factor based on this calculation is say 0.25, right? And then based on the table that I'll show you for the north side, now say this is a north facing fenestration, right? Based on this projection factor, say the M factor is say say 1.15, right? Now my manufacturer provided Ssgc, manufacturer provided Ssgc, it says 0.5, right? Now based on this, my effective Ssgc is this divided by this. So that means 0.43. But then you have to check, and then based on this calculation, you have to see that whether I meet now these requirements provided in ECBC table 4.10 or not, right? So for example, I have taken this for north projection. So with a 0.43 effective Ssgc, I meet the requirement of ECBC compliant buildings for north facing windows that lies above the latitude of 15° north. So yeah, this is how you can calculate your effective Ssgc. Are there any questions so far? Is this calculation easily followable? Is it too complicated, or you want a further explanation of this? You can raise your hands. Okay, I'll just go through this. Now, as we can see that apart from Ssgc U value, the third component that is there for fenestration is the visual light transmittance. Now, this is something that is required for daylighting. Now, daylighting is a compulsory requirement under ECBC 2017. That means you have to meet the daylight requirements of these places, right? Now, here, as you can see that what visual light transmittance is a fraction of visible light transmitted through the glazing. Now, this is a factor, and the value varies from 0 to 1, right? So, higher the insulating property, glass will reduce daylight. That means higher the insulation, lower visible light will cross through this. Hence, there is a balance that needs to be maintained while you're designing ECBC compliant buildings. You cannot keep your glazing too low so that you don't meet the daylight requirement, or you cannot keep your visual light transmittance too high so that you don't meet the U value J factor. So in that case, you always have to maintain a balance in between U value and the PLT, as because daylight is a mandatory compliance under ECBC. So this provides a small comparison of the different glass assemblies. So as you can see that you have single glaze clear glass, you have single glaze tinted glass, double glaze high solar gain low E glass, and double glaze low solar gain low E glass. So as you can see that U factors are differ largely in between single glaze and a double glaze glass, but then in clear glass, the VLT, I mean the percent of your visual light transmittance is about 98%, whereas the VLT in this is 78. I think this is wrong. 78, right? Right. Okay. So that means if you choose a double glazed high solar gain but low E glass, your Ssgc will be quite higher. In that case, you have to provide shading to meet the Ssgc requirements of ECBC. But in that case, your VLT is also higher. That means you will be able to meet the daylight requirements as well. But in a double glazed low solar gain low E glass, you will meet the Ssgc requirement without planning for some shading device, but then your VLT will be lower. So you have to calculate what your daylight would be in the space to make that decision that which glass I should go for. Now, wall to window ratio, after so depending on the amount of window that you have on your building envelope, that is a main factor for the heat gain, because maximum heat gain, as we saw, happens through the glazing only. That means if we limit our glazing, we will be able to limit the cooling of the building. So as you can see that the maximum allowable wall to window ratio is 40%, but this is applicable to buildings showing compliance using the prescriptive method only. So if you're showing the ECBC compliance through prescriptive, you have to keep your WWR within 40%. That means your glazing area should not exceed 40% of your entire external wall area. But if you are doing the ECBC compliance through whole building simulation, you may choose to exceed this 48%. In that case, you will have to put high performance glass so as to meet the ECBC requirement. So again, that is again one of the factors you need to consider, because a lot of buildings they have or they sell on aesthetics. That means you need to have commercial spaces like malls and everything. They need to have glazings sections that has to be higher than 40%. If that is the case, you have to show compliance of ECBC through the whole building simulation method, and in that case you have to invest in the glass so that your energy consumption of the building does not exceed that of the standard building. Now, when we come to the simulation through Equest, there is a catch in this. Whenever you are doing a standard building, energy model through Equest or any energy simulation software, your wall to window ratio should not exceed 40% in the standard building. Your proposed building will have whatever percentage it has. If it is a mall and if it has 60% wall to window ratio, then that has to be 60%. But in the standard case, it can only be maximum 40% in the standard building. So that means if you have a high WWR and you have to show ECBC compliance through whole building simulation, you are on a disadvantage from the first moment, because in your standard case, your glass is limited to 40% only. So that 20% extra glass or in your proposed will amount to that heat gain anyways, right? So this is one of the tricky things that you have to play around with. Now, Skylight roof area, again, through ECBC, they limit the Skylight roof area to 5% of the roof area only if you are proving compliance to prescriptive. If you are going by the whole building simulation, you can choose to have more skylight than 5% of the roof area, right? Another factor that influences the effectiveness of the building envelope is the air leakage. So if your junctions between wall and other walls and floors, electrical equipments, junctions between window frames and walls, access doors and other penetrations, if they are not sealed properly, then there will be air leakage, and then that will amount to inefficiency or not high effectiveness of the building envelope. You may choose to put a very highly efficient wall, but then if air leakages happen, in that case, that building envelope will not act as effectively as it can. Hence, ECBC provides some mandatory requirements on the air leakage part as well. Now we come to the daylight. As we said, that daylight is a mandatory requirement for ECBC. So if you can see that daylight is a practice of placing windows or other openings and reflective surface so that during the during the day, natural light provides effective internal lighting. Now, if I come to the next slide, we need to keep one thing in mind, that we need to have daylight, but then the lighting also it has to meet the visual comforts of the space usage. We cannot have just in order to have a daylight, we cannot choose to have higher glare. Of course, there isn't much. As per ECBC, you can. There is a limit that you can have, right? So how ECBC controls daylight is through the daylight factor. Now, this is the thing that you have to calculate. Now, daylight factor characterizes the amount of daylight a space might receive compared to what is available from the sky. DF is commonly estimated over a working plane, example on a disk surface. So that means, this is the the formula for calculating the daylight factor is that is inside illuminance divided by outside illuminance, and daylight factor is represented as a percentage. Now this desk surface, it is generally 0.7 meter from the ground, right? So you have to calculate if you're doing a daylight simulation through BEE approved softwares. In that case, you have to keep the evaluation plane at 0.7 or 0.72. I think we keep it as at 0.7, right? And then ECBC says that within the room space, useful daylight illuminance should be achieved. That means that daylight levels that are useful to occupants, that is, it is neither too dark, that means it should be above 100 lux, or not too bright, that is, it should be underneath 2000 lux. That means the lux level within the rooms meeting the daylight shall range from 100 lux to 2000 lux. So based on that, when you are designing your building envelope, these are some of the factors that you have to consider. First is the altitude. That means how that will determine your solar gains based on the altitude, based on the soil, the wind direction around structure, vegetation, and water bodies. All of this together influence your microclimatic conditions within that area for which you are designing your building. Now, here what we can do is we can see how different type of building shapes or design patterns, they help you for building design components. For example, if you see that longer oriented facades along the north will provide you glare-free light in the summer from north without shading, and winter sun penetration from the south, right? So what you can do, I can show you. So I think we can quickly have a look at this during our Equest exercise, that how changing the shape of the building quickly gives you the impact on the total energy your consumption on of the building. We'll take this up more in that Equest thing. That ways it will be much more clearer. Now, for the building envelope, as we said yesterday, that under every component there are certain mandatory requirements that has to be complied, irrespective of whether you're going through prescriptive or whole building simulation. And then there are some prescriptive requirements, then trade-off. Trade-off, as I said, it was you can choose not to meet certain prescriptive requirements until and unless the overall aim is achieved. So what are the mandatory requirements? As you can see that there are some mandatory requirements for the fenestration, solar heat gain, so the VLT requirements, the solar heat gain coefficient requirements, and U factor requirements. These are the mandatory requirements. For opaque surfaces, the only mandatory requirements, as I said earlier, was the U factor calculation has to be in accordance with ISO 6946. Also, you need to have a third-party laboratory checking your U value compliances. The third mandatory requirement under section 4.2 is the daylight. The daylight says that useful daylight illuminance has to be met for ECBC, ECBC plus, and super ECBC compliant buildings. Now, under this, you can prove daylight through daylight simulation or manual daylight calculation as well. I'll just quickly show you what the daylight calculation looks like. Oops. Yeah. So in here, see, this is what the requirement is. Based on this requirement, if you are designing a business building and you want your business building to be ECBC compliant, then 40% of your above grade floor area shall meet the UDI requirements. And the UDI requirement is 100 lux and 200 lux. That means 40%. That means in 40% of your above grade floor area, the illuminance level should be ranging from 100 lux to 2000 lux, right? That is the requirement of ECBC. But if you want your building to be ECBC plus compliant, then 50% of your area should have illuminance level of 100 lux to 2000 lux. And if you're going for super ECBC, then 60% of your above grade floor area shall have the shall range from 100 lux to 2000 lux. So if you are now, as you as I said, that you can meet the daylight requirement through simulation, like in that you have to take measurement. I'm sorry, is 0.8 meter above the finished floor. That is the working plane. Now, ECBC provides a number of softwares that you can use. So if you just if you can see, right. Yep. If you see, these are the list of ECBC approved daylight simulation software, which is DaySim, Design Builder, Diva, Groundhog, IAS, Open Studio, Radiance, Rhino, Grasshopper, then Sapphira. So all these are ECBC approved simulation softwares that you can use for your daylight simulation. And also ECBC also provides whole building performance approved software. So as you can see, Equest that we are going to learn, it is a BEE approved software, right? Yep. So that is a separate exercise in itself, daylight simulation. But what I will do is I will quickly show here the manual calculation method. Now, as you can see, that based on the location of your windows and based on whether you have any shading or not, you have determined the projection factor. If you remember how we determine the projection factor, this is the way. That means the extension of the shading divided by the vertical height of the shading from the base of the fenestration. This is how you calculate the PF. Now, based on the PF and based on which side your facade is and your visual light transmittance, you have to determine what is your daylight extent factors. So say if you have a shading and your projection factor is higher than 0.4, then windows without light shell, and then if you have a north facing window, right, that has a VLT above 3, then your daylight extension factor is 3, right? Just like that, you have to determine your daylight extension factors for all the directions and all windows, and then based on that, yeah, this is a good representation. So as you can see, this is the floor plan. These are the locations of the so I'll just quickly keep this pen here. So as you can see, these are the locations of the windows here, right? This is also one huge yeah, fenestration here. These are fenestration. So based on this, the UDI was determined, and as you can see, and then based on this, all these highlighted spaces, right, this meant that all these meet the UDI requirement, that is 100 lux to 2000 lux. Now if I see the calculation here, yeah, so if I see the calculation here, how do I go? So as you can see, for north, for the identified daylight effective VA factor and based on the fenestration width, right, we calculate the area, right? So if you so it is quite well explained in this table 4.4.1. You can do this calculation manually. If you have your door window schedule on your Excel, it will be very easy for you. Only that the common areas, like you cannot double count the daylight extension from two windows. So for example, if the daylight extension from this fenestration S1 and W4 is this and this, then the common area has to be removed, right? So after removing all these common areas, then you get the total amount of area that meets the daylight UDI requirements based on this calculation. So if you go through it, it is a very simple calculation. It is quite straightforward, and then after calculating this for every floor and then dividing that by the total GFA above ground, you will get a percentage. So for example, for this example, 49.2% of the total above grade floor area meets the UDI requirement. That means it is ECBC compliant, because as per ECBC compliance, 40% of business and educational spaces need to meet the UDI requirement to be called as ECBC compliant. Now, just remember that all assembly buildings are exempted from from daylight requirement. That means and assembly buildings are theaters, multiplexes, and stuff, because there in multiplexes it is not possible to have 40% of a daylight, because you need theaters to run and everything. So all assembly buildings are exempted from the requirement of the daylight assessment. So are there any questions so far? Please feel free to raise your hand or ask anything.
So there's a question: is there any lower limit for WWR?
Is there any lower limit? No. There are no lower limits. I mean, at the end of the day, WWR, if like if there is no window at all, right? Then of course your heat requirement or your cooling requirement will be uh, most effective. But then at the end of the day, you need to have that. You need to see whether you can have any building without any uh, window, right? Until and unless it is a warehouse or something. But then again, you have to see that under what categorization warehouses would come, right? So again, I mean, ECEBC does not prescribe any lower limit for WWR. Any further questions? What I can do is I can share with you this, like not, well, I will share with you this entire presentation, and then you can go through it and come up with any questions. What I'll do now is I think we can start. I'll just give you a brief overview of the Equest software, and then while I go through the Equest software, I will take references from ECBC. I'll show that, okay, this is what ECBC says, and this is what we are doing in the Equest software, right? So, so yeah, that ways I'll just quickly give you an overview of Equest software. So this is so after you install your Equest, this is the icon. This is how it will look. I mean, I have a Equest version 3.65. So what I'll do, so if I open this, the first thing that it prompts is whether you want to open a recent project, or you want to select an existing project, or you want to create a new project. Just asking, so does everyone have Equest installed? I mean, everyone who is on this board. Shrikant, have we shared a sample weather file for Trivandrum? Or
Sorry, sir.
hmm?
Yeah. We already shared, sir. The weather file already.
Okay. If anyone does not have the weather file, you can raise your hand so that we can share with you, because without weather files, it will not work. I mean, you can choose whatever is there, but then those locations are mostly US and Canada based. So if you want to run a simulation for Trivandrum or any city here, you will not be able to. Okay. So once I open this, the first thing that props up is this dialog box, and in here, as we are starting Equest for the first time, we do create a new project via the wizard, and then I select OK. When I select OK, it gives me two options: schematic design wizard and a design development wizard. Now, schematic design wizard is something where you can develop and run quick simulations, right? When your project is in a very early stage, you can use the schematic design wizard where things are still in the process of being finalizing, LPDs, building sections or anything, or where you want to do those quick trade-off calculations to see that okay, if I do this, if I'm meeting the ECBC or not, or if you want to change those envelopes, have different U values and all. So all those things can be done in the schematic design wizard. In the design development wizard, it is much more detailed, right? So for this entire course, we will take the schematic design wizard. Now please note that once you have done a project in schematic design, you can always go from schematic design toward design development wizard, right? But if you have developed the model in the design development wizard, you cannot come back to schematic, right? So at any point you can update the schematic design wizard thing into a design development, but you can never come back. So I would suggest that start preparing your models with the schematic design wizard, and then when things are more complex and things, you can always update your schematic design wizard into your design development wizard. So I start with schematic. Now the first thing it shows me is what is the project name, what is the building type, what is the code analysis, location, region, city, jurisdiction, and electricity, gas, and all these things. Now, based on the choice of the location, right? Based on the choice of this location, all of this electricity, city, gas rates, and everything will change. But then we don't need it at the moment, right? We'll go through this. I mean, we'll do a perfect hands-on example starting in the afternoon session. But I'm just quickly giving you an overview of the Equest here, right? Then, if we go to the so here we can give in the basic area details, the HVAC and other things. So this building area is the
Meso,
yep.
sir, there is a hand raise from Subramanian CV. Shall I
Sure, please.
unmute him?
Please.
Hi, sir.
Hello.
Hello, Subramanian, sir. No, just we can leave. And one more, Suraj MS.
Actually, we have a screen showing the PIP port. We can't see the EQs.
You have the screen
The
showing?
poll will be closed now. Just a moment. We are just closing that.
Yes, yes.
Oh, the poll.
You can continue, sir. Thank you, sir.
Okay, no problem. So as you can see, yeah, earlier also, were you able to see how I chose the schematic design, or shall I start again?
I think 1 second, sir, please.
Okay, sure, no problem. Okay, so as you can see, this is the Equest icon. So if you double click this will be the first screen that comes. Now, as we are doing a new project here, we'll choose this create a new project via the wizard and click OK. But if you have existing projects, you will have to select this, or if you choose this open recent project, this will open the last session project that you were working on Equest. So say if I'm working now on say the sports block here, right? And then I close it and then I again start Equest 2 hours later. So instead of going and you're selecting again project, I can directly open a recent project and this will open the sports block only, right? So just like that, as we are doing it for the first time, we'll choose this option of create a new project via wizard and we'll click OK. Once we click OK, we come to this dialog box that allows us to choose that whether we want to make a schematic design wizard or a design development wizard. Schematic design wizard is something where you do those early concept design scenario analysis, where you can see that okay, by changing the shape of the building, how my energy analysis is here changing. If I use a different glass, how is it changing? If I add 100 of extra space, how is it changing? I mean, all those things you can also do in this as well, in the design development. But then the schematic design, it is much more simpler that ways, right? Where you have simple schedules, simple assignments for internal loads and things. Whereas detailed design, you can do much more detailed analysis once your designs are finalized, and then you want to see that whether the final designs are ECBC compliant or not. So, and just for a note, you can always switch from schematic to the design development, but you can never switch back from the design development to the schematic. So for this session, we'll choose the schematic, and as we choose it, it gives us this block where it asks for the project name, what type of building it is, right? So if I just say ECBC practice project, right? So this is and these are the options of the type of buildings that you can choose from. Now the way this influences is if you choose a multi-family high-rise. So default schedules profiles of a multi-family high-rise will be chosen in this automatically. So for this, we'll choose the one that Shrikant has already shared with all. Yes, Shrikant, is it commercial or what was it that has been shared?
It's commercial, sir.
Okay, so it's a commercial. So I'll just go and I'll say office two-story. Yeah, I'll just go and say office building 2-story. Now, as I choose this, all the later on things will be, all the profiles, schedules, and everything will be automatically applied to the project. Now, we can always go back and change those, but for the sake of this, we'll just use those default things as well. Now, you have to set the location. Now, setting location, again, everything will be based on the weather file that you have chosen. So I think Shrikant has already shared it here with you. So as you see, if I go and select the user selected option, then everything goes back, goes blank, and it asks me to choose a weather file. That way, if I choose, all the weather files are automatically saved where you have in the Equest directory. So is anyone so is everyone having this page here? Shrikant, can you take a quick poll of this? I'll just quickly see if people can see this or not.
We'll do that. So, which poll, sir? Weather file or?
No, like whether people are getting the same screen that I'm having right now, whether it is taking them to the documents in the Equest directory or not.
Someone not getting, sir. Getting the folder.
Okay. Did they change this option to users selected and then clicked on this small box here?
Just one, sir. Just one. I am just closing the poll right now. Just one, sir. Yeah. Now you can tell, sir.
Okay. So to open this dialog box, you have to choose this user selected option. And once you have chosen this and click on the small box that is set above right side to this weather file, that ways it will take you here. And then here in the data, you will have in the Equest 365 data, you will have a folder called weather. And then within the weather, you will find, say, so for example, I have this Amritsar weather file here. So the weather file that Shrikant has shared with you all should be saved in this Equest data directory, weather, in this year folder anywhere, right? So for example, I have this, if I choose, so it chooses the Amritsar weather file. Now, whatever weather file you have that Shrikant has shared, just make sure that you save it in this location. That means you go to my documents. If you go to documents and so if you already have installed Equest, and if you go to documents, you will see Equest data folder already in there. And then if you open that, you will see down there is a folder called weather. To save inside this the file that Shrikant has already shared here with you. Is this so? Has everyone already installed it? I think, well, as this session is recorded, you can always go back and you refer to this session to see how it is. Now, just going through this, there are 43 options that you can go through, but I would suggest that you choose the weather file rightly here, right? And well, and you finish the project right now, that we can take up in the afternoon. So as you can see, this is my so if you click finish on the so if you click, so after choosing the weather file, if you click finish down here, it will generate so it will render a default model that is there. And if you see the 3D, it will show you that these are the three so yeah, this is a default building that Equest has created here for you. But we will develop a separate one based on the AutoCAD drawing that that Shrikant has already shared with you. So just finish. So just click on finish, and then save this. What? Just save this so that we can continue with the same model in the afternoon. Now, just as you can see that I've saved it with ECBC practice project. Now, just I'll just show you where this is saved. Yeah. So as you can see that if you go to documents in this, there is Equest 365 projects. If you go, so a folder has already been created in the name of ECBC practice project. So all ECBC files or all ECBC folders that you have done is automatically created and saved in this your in documents Equest 365 projects, right? Just save this one for now, and then we'll carry on with the Equest and the hands-on practice in the from the second session onwards, right? So I'll just quickly open the floor for any questions that you have. If you are facing any difficulty or so, right? So open to the audience. Please feel free to raise anything.
Sir, I will unmute all the audience. You can ask questions.
Okay, so if there aren't any questions, we can end this session now, and we can reconvene in the afternoon.
I think there is no more questions, sir.
Okay. Great. So we start at 2:30, right, or 2 o'clock?
2:30 is okay, right, sir?
Yeah, it's fine. Give it me. I was just confirming it.
Yeah, then
Like
we can start with 2:30, sir.
Okay.
Fine, sir.
Sure. Okay.
Participants, morning session we can end with this. For all of you should install the Equest software for the next session to be it will be very good if you have the Equest software with you, so that you can practice at the time itself. If you have any problem with the Equest software, you can tell now itself, so that we can we can help you. I think there is no problem, so we can end up for the time being.
Okay, great.
Thank you very much, sir.
Thank you. Thank you, Shrikant, and thank you everyone here for joining in this session. Thank you so much.